Hello everyone, I am Mithil Rajai. Welcome to lecture 4 of capacitors. In today's video, we have 4 parallel plates of capacitor or 4 parallel conducting plates such a way that the top and the bottom plates are connected. The question here is quite simple. We have to find capacitors equivalent capacitance across A and B. So pause the video here and try the question. Alright, let's solve this. So to solve such kind of questions, what you need to make sure is you name the plates first. So if I name the plates, let me take a beautiful blue color, say 1, 2, 3 and 4. We have 4 plates. We want to find equivalent across A and B. So what we need to do is take point 2 and 4 as A and B. Alright, because A is connected to 2 and B connected to 4. Then write other points or other plates in the middle. I can write this point 1, but I can also write this point 4 because 1 and 4 are connected. So whatever the potential of 1 is, 4 will have the same potential. Now one simple thing is 2 and 1 will have a direct capacitance between them. So I can say that 2 and 1 have one capacitors between them. Similarly, there is one capacitor between 2 and 3. So 2 and 3 directly also share one capacitor. Also 3 and 4 have one capacitor. So this way we have 3 capacitors, one between 1 and 2, 2 and 3 and 3 and 4. And 1 and 4 are same potential points. Let me say this is C, this is C and this is also C. And by the way, what is C? C is epsilon naught A, or let me say the area A square by D, where A square is the area of the plate. So here now you can find the equivalent capacitance across A and B. C and C in series, so that will become C by 2. C by 2 and C in parallel, so C by 2 and C will become 3C by 2. So equivalent capacitance between A and B is C by 2 plus C, which is 3C by 2, which makes it 3 by 2 epsilon naught A square by B. Quite simple, right? Let's see the next question. Here instead of 4 plates we have 5 plates, and the first plate and the fourth plate are connected, the third and the fifth one are connected, and you have to find equivalent between this plate second and 3 and 5. Okay, B point is 3 and 5. The question is same, you have to find equivalent capacitance between A and B. You can pause the video or you can keep watching. So to solve this, first of all, as I said, number the plates. So I'll number them. This is 1, 2, 3, 4 and 5. Now we have to find equivalent between 2 and that is A and B. So A is connected to 2 and B is connected to both 3 and 5, where 3 and 5 will have same potential. So I am writing these points 2 and 3, 5. This is A, this is B. Further, we have other points 1, 4, right? 1 and 4. and they both are connected, so I can write 1 and 4 here. You can draw this point anywhere you want, it's up to you. What next? Next, you find out which are the capacitors. There is one capacitor between 2 and 1, so you can draw one capacitor between 2 and 1. Now when you draw between 2 and 1 or 2 or 4, it's the same thing. So this capacitor is sorted. Between 2 and 3 there is one capacitor directly. So between 2 and 3 there is one capacitor. Between 3 and 4 there is one capacitor. Between 4 and 5 there is one capacitor. So between 4 and 5, that is 4 and 3. So that's it. All the capacitors are same because the distance between the plates is identical. All the 4 capacitors are noted here. Now you have to find the equivalent of all of these. This C and this C will become 2C. 2C and C in series. 2C and C in series will give you 2C into C by 2C plus C. This will be 2C by 3, equivalent of the upper branch. Then 2C by 3 is in series with this C. So total capacitance between A and B will be 2C by 3 plus C, which will make it 5C by 3. And what is C, by the way? C is epsilon naught A square by D. So you can put this here, 5 by 3 epsilon naught A square by D. Alright, let's see the next thing. Now this question is similar to the one we solved earlier, right? But the only difference is now we have a battery across it. But the question is different. What we have to find is not the equivalent capacitance. Instead, we have to find charge distribution. Charge distribution. What do I mean by charge distribution? It means that you have to find charge on each side of each of the plates. Okay, what is the charge here? What is the charge here? What is the charge here? Here, 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 and here. You have to find charges on either side of all the plates. So you can pause the video and try the question. Alright, let's try to solve it. Here, first of all, remember that equivalent of this whole circuit, equivalent capacitance is 3C by 2. Alright, 3C by 2. So the whole circuit is like this. This is A, or the battery is connected across this one. Okay, this is V. All the capacitors are C, C, and C. Now since equivalent is 3C by 2, 3C by 2 is the equivalent, a total charge of CV, that is 3C by 2 into V, that is 3CV by 2, is given by the battery to the capacitors, to the whole circuit. Alright, so this 3CV by 2 will get distributed, and the 3CV by 2 will also come back. Alright, because the battery cannot generate charge. So what I mean is that total charge on these plates, which plates? these two plates, the total charge should be 3 CV by 2 positive, and on these plates should be minus 3 CV by 2. Okay, and what do I mean by that? I mean that if this battery gives 3 CV by 2 charge, then the total charge on this plate is 3 CV by 2, and total charge on this plate is minus 3 CV by 2. Alright, so let's start solving. One thing we know here is the potential of this point. Okay, the potential of this point. Let me say this potential is 0, this potential is V. Alright, so potential here is also V, potential here is 0. These two capacitors are connected across V and 0, and they are identical. So potential at this point will be V by 2, half the potential drop. Alright, so this capacitor, the first capacitor between the plates 1, 2, between the plates 1 and 2 is across a potential difference of V by 2. So the charge in this capacitor will be CV by 2. Yes or no? Charge is capacitance into potential difference. So charge on this capacitor will be CV by 2. We already know that outside the plates the charges are always 0. I hope you know this. Whenever we have parallel plate capacitor, the charges are always residing on the inner side of the plates, never on the outer side. Okay, so if this is 0 and the potential and the total charge on the capacitor is CV by 2, then here will be minus CV by 2, and on this plate will be plus CV by 2. Yes or no? Minus CV by 2 and plus CV by 2. Here, if it is CV by 2 here and total charge given by the battery is 3 CV by 2, then this one will have CV by CV plus CV. So that plus CV plus CV by 2 becomes 3 CV by 2. If this has CV, then this one will have minus CV, because they are opposite sides of a capacitor. If this one has minus CV and total charge on this whole plate is minus 3 CV by 2 as mentioned earlier, then this one will have minus CV by 2. If this one has minus CV by 2, then this one will have plus CV by 2. So this is how the charge is distributed. You can also check whether your calculation is correct or not by looking at the plates 1 and 4. Plates 1 and 4 were never connected to battery. They were completely isolated. Yes or no? So total charge on 1 and 4 should always be 0. Check it out if it is coming out to be 0. Here it is plus CV by 2, here it is minus CV by 2. So 0, 0 and 0 also 0. So our calculations seem correct. So this is how the charges are distributed across the 4 plates.